All right, in review for the second test, let's go through some different example problems. Here is Chapter 6, Section 3, number 17. As you can see through reading it, an airline claims that 72% of all its flights to a certain region arrive on time. So we've got the 72%, which is most likely going to be our sample proportion, not our sample proportion, but our population proportion. So let's continue reading. In a random sample of 30 recent arrivals, so we have n because we have a sample size of 30. 19 were on time, so we have 19 out of 30, which is going to be how many in that particular sample for that proportion. So if we look at that proportion, we can say that our p hat equals that 19 divided by 30, or 0.6333, and on and on and on. Now that I didn't do that in my head, I actually used a calculator on that one, so we'll go with that. It says we can assume the normal distribution applies. Good, so sample proportion A, well, we just did A right there. There's A. B. So in B, assume the airline's claim is true. Find the probability of a sample size 30 producing a sample proportion so low as was observed in the sample. So we're looking at here on a sample proportion. We know that that's a normal distribution, that the mean or the proportion of samples is mean. So here we have the proportion being at 0.72. And we're looking at here is what's the probability that of our sample observation of 0.6333. So what's the probability that it's that or lower? So low as we observe, so from there or below. So what we'll be looking at here for B is the probability that, I'll just use X here, is less than or equal to, that looks like a set thing, less than or equal to the 0.6333. All right, so first thing we need to do is double check that we are able to use our normal assumption. So that's where we had the NP and the greater than or equal to 5, as well as NQ being greater than or equal to 5. So that's 30 times our 0.72, and 30 times 1 minus 0.72. We'll say 1 minus 0.72. Check what those are. And 30 times 0.72, so 0.7 times 30, that's around 21. 21 is way bigger than 5, okay. And 0.72, so that's 0.28, about 0.3. 0.3 times 3, 30 is about 9, which is greater than or equal to 5. So I could actually use the calculator and calculate those, or like I just did in my head, saying, yep, those targets fit. Okay, so we've got the actual mean. The sample population in this case is the same as the proportion, so this is the 0.72. Our standard deviation is the square root of P times Q over N. So in this case, the square root of the 0.72 times 0.28 over our sample size is 30, which equals 0.082. All right, then we're going to go and calculate our proportion here. So that X is less than or equal to 0.6333, which is the same as if we convert this over to our standard normal. So the typical way we're doing that one is we've got our sample here, the 0.6333, minus the mean, which is 0.72, divided by the standard deviation, 0.082. Those of you who are paying attention up here, that was a 0 that I made drawing kind of funny, which is equal to the probability that Z, you make those Z's, less than or equal to minus 1.057 So if we look in our chart, standard normal chart, 1.057, that's the closest one in our chart is going to be minus 1.06. And at 1.06, so the probability of z less than or equal to minus 1.06 equals 0.1446. So there's B. So the probability of finding a sample size 30 producing a sample proportion so low is, in other words, 30 or lower, is going to be 0.14 or about 14%. There we go, number 17.